Welcome to another episode of Learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Yes, this is my channel. Please subscribe my channel if you have not already subscribed. Thank you. Right. We now discuss the solutions of the problems that have appeared in the IIT JAM Mathematics 2024 examination. In this video, we discuss the solution of a problem from the section Real Analysis, which is related to sequences and series. And this question is a multiple choice question for 2 marks, and the question number is 21. This question is suitable for all these examinations. Especially, this question is suitable for JL, DL, TG set and AP set examinations. Right. The given question is for P, Q, R belongs to the set of real numbers. P, Q, R are real numbers, are not equal to 0, non-zero real number, and n belongs to n. N is a natural number. Let an, the nth term, an is equal to P power n power q into n by n plus 2 whole to the power of n square, and Bn is equal to n power n by n factorial into r power n in the denominator multiplied by the under the square root of n plus 2 by n. Then which one of the following statements is true? We are given 4 options. Option A, if 1 less than P less than is square and Q greater than 1, then sigma an is convergent. Option B, if E square less than P less than e power 4 and Q greater than 1, then sigma an is convergent. In both the cases, Q greater than 1. That means in the discussion of sigma an, we can as well take Q is positive. Option C, if 1 less than or less than E, then sigma Bn is convergent. Option D, if 1 by E less than or less than 1, then sigma Bn is convergent. Right. Let's now discuss the solution of the problem in detail. First of all, take the first series. Given an is P power n power q multiplied by n plus 2 whole to the power of n square, where n is a natural number and P, Q are real numbers. We discuss the convergence / divergence of the series sigma an. Right. Note that each term an is positive for all n belongs to n. Here we assume for the time being P, Q greater than 0. It's not P, it is Q. It is Q. Right. Now, limit n tends to infinity, an to the power of 1 by n. Why are we going for that? Look at an. an in that n by n plus 2 to the power of n square. There is a power, n square is there. It is better you go to a test, what is called the Cauchy's nth root test. So we are trying for that. limit n tends to infinity of an to the power of 1 by n, that is equal to limit n tends to infinity of p power n power q multiplied by n plus 2 whole to the power of n square whole to the power of 1 by n. So p power n whole to the power of 1 by n is p, and n by n to the power of q to the power of 1 by n is n to the power of q by n, and this is as it is, and the power n square will become n now, because n square into 1 by n is n. Now limit p is free from n, therefore p comes out. Limit n tends to infinity of n to the power of q by n into limit n tends to infinity of n by n plus 2 to the power of n. The limit of the product is equal to product of the limits, you are using that, and that is equal to p into limit n tends to infinity of n to the power of 1 by n to the power of q multiplied by limit n tends to infinity of 1 by 1 plus 2 by n. So you have taken a n common in the denominator, thereby n into 1 plus 2 by n, that n and that n cancel, and you got this one. And limit n tends to infinity of 1 by 1 plus 2 by n to the power of n is a well-known limit, and it is e square. And you know limit n tends to infinity of n to the power of 1 by n. The nth root of n when limit n tends to infinity will be 1. So this will be p into, this is 1, this is 1 by e square, that is p by e square. Right. Now recall the Cauchy's nth root test. It says let sigma an be a series of positive real numbers. Let limit n tends to infinity of an to the power of 1 by n is L. Then the series sigma an is convergent, first case, when L less than 1, divergent, second case, when L greater than 1. The test fails when L is equal to 1 and requires further investigation. Right. We call on, now using this Cauchy's root test, sigma an is convergent if p by e square is less than 1. If p by e square is less than 1, this is L. So now we call on option A, if 1 less than, p less than e square and q greater than 1, then sigma n is equal to 1 to infinity an is convergent. So in the beginning we said each term an is positive for all n belongs to n, and for the time being we assume q is positive, but it is q given to be 1, no problems, and all the things will follow. Right. Take this 1 less than p less than e square and divide throughout by e square. You will get 1 by e square is less than p by e square is less than 1. Now you will see p by e square is less than 1 in this case. Therefore, the series is convergent. Right. Option A is true. Now go to the option B. Option B. If e square less than p less than e to the power of 4 and q greater than 1, then sigma n is convergent. Right, q greater than 1, and we have assumed q is positive, and it is given q greater than 1, no problems, everything will follow. And take the inequality e square less than p less than e to the power of 4 and divide throughout by e square. Then you will get 1 less than p by e square less than e square, and 1 less than p by e square means p by e square is greater than 1. Therefore, by the nth root to test, this series is divergent. Therefore, option B is not true. So so far option A is true, right? It is a, right? So that is the one. It's a multiple choice question. Therefore, you can stop here. Only one answer will be there. But anyway, we'll show you what happens in the remaining two options. Right. In the second series, we are given Bn is equal to B suffix n power n by n factorial into r power n under the square root of n plus 2 by n belongs to n, r not equal to 0. We want to discuss the convergence and divergence of this series. Note that each term of the series Bn greater than 0, for all n belongs to n, we assume for the time being r greater than 0, no problems. Thereby Bn will be greater than 0. Agreed. Now we are trying to apply what the D'Alembert's ratio test. For that we compute Bn plus 1 by Bn is, this is Bn plus 1 by Bn is written in a reverted fashion. Now cancel n factorial with n plus 1 factorial and n plus 1 will remain here. R power n cancel with r power n plus 1 and r will remain here. So that's what we have. Now you cancel n plus 1 with n plus 1 to the power of n plus 1. After cancellation, it will be n plus 1 to the power of n. That you club with 1 by n power n, and that will be n plus 1 by n whole to the power of n. And these two will get multiplied. So 1 by r into n plus 1 by n to the power of n, these are clubbed here. And now limit n tends to infinity of Bn plus 1 by Bn is limit n tends to infinity of 1 by r into n plus 1 by n whole to the power of n into under the square root of n into n plus 3 by n plus 1 into n plus 2. 1 by r into limit n tends to infinity of this, take a n common in the numerator, cancel with the denominator, and you will get 1 plus 1 by n to the power of n. And it is a famous limit. The limit n tends to infinity will be exponential. Limit n tends to infinity of, take the, in the numerator, take n common, n into 1 plus 3 by n, there is already n square into. In the denominator, take n common from n plus 1 and take n common from n plus 2, and that will be this one. Now take the limits as n tends to infinity, 1 by r is constant, and this is the exponential multiplied by this is 1. This is 1 by 1. So that is 1 by r into e by r. Agreed. This is e by r. Now call on, let's recall ratio test. Let sigma a n be series of positive real numbers, and let limit n tends to infinity of a n plus 1 by a n, the ratio is equal to L. Then the series sigma a n is convergent, first case when L less than 1. Second case, when L greater than 1, it is divergent, and the test fails if when L is equal to 1, and we require further investigation. Agreed. Now, by ratio test, using this, the series sigma Bn is convergent if E by R less than 1. So let's call on option C. If 1 less than R less than E, then sigma Bn is convergent. 1 less than R less than E. So here he has already given R greater than 1. So there is we do not lose any generality by assuming here for the time being R greater than 0. No problem. Everything will follow. So you divide by R, you will get 1 by R less than 1 less than E by R. 1 less than E by R is E by R greater than 1. Use the ratio test, it is not convergent. Sigma Bn is not convergent, it's divergent, and option C is not true. Call on option D. If 1 by E less than R less than 1, so R is positive but less than 1. So we did not lose any generality by assuming r greater than 0 in the beginning. No, everything will follow, no problems. And sigma Bn is convergent. Now, 1 by e less than r less than 1, and you divide throughout by r, no problems. R is not 0. 1 by r, you multiply by e and divide by r. Inequality will not get disturbed, no problems. 1 by r less than e by r. So that means e less than e by r. That means e by r is greater than e, where e greater than 1. So e by r is greater than 1. Therefore, by ratio test, it is divergent. And option D is not true. Combining all the options, the answer to this question is option A. That is the detailed discussion of the solution of this problem. And the problem is based on two tests. One is a Cauchy's nth root test, and the second one is the D'Alembert's ratio test. So this story tells you that for all the BSc students, I am telling, that you require a thorough knowledge of the tests of convergence. So like direct comparison test, limit comparison test, P-series test, and nth root test, ratio test, and so on and so forth. Even Cauchy's condensation test, even though you have not studied in your BSc, if you have not studied in certain parts of our country, especially in South, we do not teach at BSc level Cauchy's condensation test. So those of you who have not studied, please get familiarized with Cauchy's condensation test, and that will be most useful for you. So with these few words, I say, I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. It is my earnest request to all my students. Please join as a member in my channel and support me and my channel. Yes, this is my channel. Please subscribe my channel if you have not already subscribed. Yes, I am sure I will be meeting all of you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.